this is what is kind of let's say overwriting the instruction pointer. And thing is that what this instruction pointer is doing is that what I will do now is that something like this. So let me just take a screenshot of this one. Okay, so what we are going to do now is that this EIP value is actually pointing to is actually pointing to 4444, and 4444 is this one that you are seeing over here. So let me just pick a bigger data. Let me just do this one. Okay, so if you see, this is the EIP value, which is 4444, right? And this is actually somewhere here in the stack memory, the specific 4444 from where the EIP is reading the data. So this is the stack memory part, right? This is the stack memory part, and this is the 4444 value over here. So what I will do is that after this DDDD, the data, this is the data that is coming out again from the data that I have shared to the server. So this data, the one that you are seeing over here, that which I have sent earlier, if you see over here, it starts with 6B, I7, B, I8B, and that's the same thing that you are seeing over here, 6B, I7, B, I8. So what I will do is that I will put my malicious payload. In this part, 6BI7. Okay, so this 6BI7, I will replace that with the malicious payload. Okay, and what I will do is that if you see, as soon as the function is returning, what I will do is that since this malicious payload over here, what is the address? The address is 0022F730. Like this is the address, right? So what I will do is that rather than writing 4444, I will replace that with this address 00224730. Okay, so I'm again repeating that. I will replace this payload, which is 6BI7, with my malicious payload. Okay, the one that I am sending out here, I will replace that with the malicious payload. Okay, and then thing is that this is the address that I am controlling, DDDD. I will replace that with the stack memory of this address 0022F730. The reason is that what will happen is that now if I give this value, the one that I'm highlighting right now, over to the instruction pointer, the instruction pointer will start executing the code, whatever it is there at this address 0022F730. Okay. And this the one thing, guys, which I was telling, ASLR, address space layout and memorization, because it is turned off in XP, it is not existing in XP. This address will be always static, no matter at any part of world you initiate the Windows XP operating system. This address will be the same, 0022F730. It will never change. But in Windows 7 or Windows 10, this is the address that will keep on changing every time the exe is run. And that's where the attacker will not be able to figure out what that specific address would be. And then we need to kind of figure out, kind of deal with that situation in a different way. But different way, like one of the technique is like NOP sled, which I will give a brief introduction. But thing is that here, this address will not be changing. So what I will be doing is, I will replace this data with the malicious payload. Okay. I will replace this 4444 with this address, and this address, once EIP points to this address, because I am able to control the EIP value, my malicious payload will run from this point. Okay, I hope there is no confusion till this statement. If there's any confusion, guys, please let me know right now. This is the correct time to let me know. Okay, and now let's proceed with further development. Okay, so I hope this is kind of interesting and easy to understand by like how I'm able to explain you guys. You're able to understand that. If there's no question, I assume like you guys are able to understand that. So now thing is that let me quickly go and figure it out. So this time what I will do is I will, let's say I will replace this value with the stack memory, which is 00222F730, right? So what I will do is I will copy this. Let me copy this. And I will replace this with this one. Okay. So it is 0022F730. It is written in reverse way. The reason is that stack actually grows from high to low. It is growing in reverse way. That's the reason why I have written the address also in a reverse way, which is 0022F730. Okay. So if I go over here, what I have done is I have written the address in reverse way, and that's too in a hexadecimal format. It's not like a string. And because it is in hexadecimal format, because the addresses are in hexadecimal, 0022F730, and that's the reason what it is not a normal string. So that's the reason I have kept /x, which denotes that this is a hexadecimal character. Okay, so I hope this till this point is correct. You are able to understand. And now what I will do is I will restart the debugger. Let me restart, and I will run it. And this time I will rerun this code, and it will again crash. And if you see, the EIP value is something like 0022F7. If you see over here, one that I am showcasing right now, over here 0022F7. 30 has been replaced with 32, but we will kind of figure that out. But that's the reason. All right. So now the thing is that it is what the EIP is doing. It has not crashed. If you have seen this time, it has not crashed, but it has paused. It has generated exception because the code that is existing in that manner is not making any sense. So the EIP is not crashing this time because the EIP last time was 444444, which is not existing in the memory. This time the memory address is at least correct. This time the memory address is, which is the EIP is pointing to, is at least correct. It is 0022F732. That's the reason it has not crashed, but it has generated an exception. If you see over here, the exception, because that code which is existing over here is not making sense to the Windows operating system. Okay. So now we are almost near to writing the complete exploit. So now let me do one thing. So guys, I'm taking it slow. If you guys even are not able to understand anything, feel free to kind of let me know, because this is very, very complex thing. Okay. So thing is that now EIP has changed. We are able to kind of do that. And now what I will do is that I will generate a malicious payload that I will replace this data with the malicious payload. And how will I do that? I will use the Metasploit tool for that. Okay. So let me use the Metasploit tool. So I have installed the Metasploit tool on my Mac operating system. And this is the specific command that I will execute. So in the Metasploit, there is a module called MSF Venom. Okay. Where I say that, okay, give me a cell code, give me a code. Okay. That will actually initiate a server in the background in the window XP. Okay. And it will, and I can kind of connect to that server and I can execute any command of my choice. Okay. So this window cell bind TCP, what it is doing is that it will generate a binary, something similar to this, the one that you are seeing over here. It will generate a hexadecimal binary of malicious payload. Okay. And what it will do is that, what this will do, it will run a different server on the host on behalf of that server. Okay. Internally, without the knowledge of the victim. And it will listen on port number 4444. Okay. And this time, if I connect to that server, it will allow me to execute any command of my choice on that system. Okay. So what I will do, I will quickly execute this command, and I say that it is 32-bit and the platform is Windows. And if I execute that, what this MSF Venom will do is that it will take some time and it will generate the binary for me. Okay. So let it generate the binary.